So yesterday we did an introduction to sequences and series and looked at just some general strategies for how to write rules, but our sequences could have been of really any type. Today we're going to focus in on one specific type of sequence that follows one specific type of rule, and that's called an arithmetic sequence. The word can also be pronounced arithmetic. And arithmetic is, just kind of our basic math, adding, subtracting, multiplying, dividing. But in a sequence name, we pronounce it arithmetic. So we kind of break up the syllables a little bit differently there. This is an arithmetic sequence. An arithmetic sequence is defined as the difference between consecutive terms is constant. What does difference mean? A subtraction. So that if I take one term and I subtract the term in front of it, this should be the same for the entire sequence. Another way of thinking about it is that we're adding the same thing each time to create the next term. Okay? The common difference is that subtraction of the terms. So if I take the second term and subtract the first term, that's our common difference. Or another way to think about it is what are we adding each time as we move through the sequence. So our first type of problem is just deciding whether or not a specific sequence follows this pattern. So for it to be arithmetic, we must add exactly the same thing each time. So I'm going to say, okay, what do I add to get from there to there? 4. Add 4, add 4, add 4. Yep, that looks good. So we would say this is arithmetic. And your book will then also, in this type of problem, ask you if it is arithmetic, what is the common difference? Our common difference is 4. It's what's being added each time. So to decide if this is arithmetic, we're going to look at the differences. I add 3. I add 5. I already know this is not arithmetic because we have to do the same thing every time. If we continue, we get 7, 9. There's a pattern to what we're adding, but for it to be arithmetic, we must be adding exactly the same thing every time. So this is not an arithmetic sequence. Okay, even though there's definitely still an adding pattern happening here, it's not adding exactly the same thing, so we would not call this arithmetic. Questions? Try the next 2 examples, determining whether or not they are arithmetic. All right, so on this one, to get from term to term, we increase by 4, we increase by 4, increase by 2. So it's important that you keep checking through because patterns can change. Then we increase by 2, increase by 4, increase by 4. So we had a little blip in the middle of this where it started doing something different. So this one is not arithmetic. So it is important that you check through the entire thing and don't just look at the first couple and decide that it's going to follow the pattern that you think. On this one, if we look at what we had 6, 6, 6, 6. So this one works out. So this is arithmetic, and our difference is 6. Yesterday we learned that when we have a sequence or a series where we are adding the same thing every time, what kind of a rule did we say that would have? A multiplication rule by whatever it is that we're adding. So we would expect our rule for this to be doing something like a 6n kind of thing, because we were adding 6 each time, but then we would need to adjust for the starting place. We actually have a formula that allows us to be able to figure out what that is without so much guess and check. Okay? You do not need to memorize this formula. It will be provided for you on the test, but we need to understand the notation of this rule. So a sub n is going to be a variable. Okay? That means any term of the sequence down the way. Okay? A sub 1 is not a variable. It is a specific term. It is the first term of the sequence. Okay? So when we see that sub 1, that means the very first number. N is a variable. That's the place in line. Okay? So that could be any place in line. So n is a variable. D is not a variable. D is that common difference. That's what we're adding each time. So we can see what happens here is we do have this common difference being multiplied by something having to do with n. But yesterday we had to do a little bit of guess and check to kind of figure out where to adjust to get the correct starting place. This formula takes care of that, so we don't need to do any guess and check here. So this asks us to write a rule and then to find the 20th term. That a sub 20 means the 20th term. So our rule is going to come from that formula. A sub n equals a sub 1 plus n minus 1 times d. A sub n is a variable. We don't want to do anything with that. A sub 1 is not a variable. A sub 1 means first number in the pattern, which is 50. N is a variable. We don't want to do anything with that. D is not a variable. D is the common difference, which is what we are adding each time as we move through this. So what do we add as we move through this? Negative 6. Okay. We always want to think about what we're adding. We don't want to necessarily think about subtraction, because subtraction is really just adding a negative. So we are adding a negative 6 as we move through this. When our terms are getting smaller like this, that difference is going to be a negative value. Now we want to go ahead and clean this up algebraically. So I'm going to distribute that negative 6. Gives negative 6n plus 6. And our rule is then going to be negative 6n plus 56. So yesterday we talked about how when we have this adding over and over and over, our rule is going to be multiplication. So we would have started with a guess of like negative 6n, but then we would have had to figure out how to adjust to get the right first answer out of it. This takes that guess and check out of it to figure out how to adjust. So this is our first answer. We were asked to write a rule. That's our rule. It says, then we also want to find a sub 20. A sub 20 would be the 20th number in this list. So we could do that. We could just keep subtracting 6 over and over until we get to the 20th one. But it's likely we're probably going to make an arithmetic mistake somewhere along the way. And even if not, it's just a little bit annoying. And what if I asked for like the 120th? That would be really annoying. So that's the nice thing about having a rule like this, is now we can plug in anything we want and figure out what number will fit that spot. So we're going to plug in a 20 for n. And when we plug in a 20 for n, we get negative 64. So the 20th term in this line would be negative 64.
What's the D?
The common difference. So it's what's being added as we move through. So to get from 50 to 44, what do we need to add? Negative 6. Other questions on this problem? Okay, go ahead and try this one. This one asks for the same thing, come up with a rule, but then this time we would want to find the 12th term in line. All right, so our rule, or our formula for our rule is going to come from a sub n is a sub 1 plus n minus 1 times d. A sub n is a variable that we don't want to do anything with. A sub 1 means first number in the line. N is a variable. D is a common difference, which is what we're adding as we move from term to term, which is 15. We always want to clean up our pattern by distributing. So we're going to distribute and get 15n minus 15. And then combine like terms, so we get 15n plus 17. So yesterday we would have known, because we're adding the same thing over and over, our rule would have to be some kind of a multiplication, so like 15 times n. But then we would have had to figure out what do we need to do to get the right numbers out of it. Here we don't have to guess about adding 17. The second part of this question says, what comes 12th in line then? So we'd want to plug 12 into this rule. And when we plug in a 12 for n, we get 197.
In the box answer you have there, you can't put in the n Are you holding 15n before the number?
It doesn't matter. Yeah, if you do 17 plus 15n, that's the same thing. And that's actually how the book usually writes it, is they put the constant number in the front. It doesn't matter. All right, the next one has the same thing it wants us to do, is to write a rule for the nth term of the sequence, but instead of giving us the beginning of the sequence, they gave us the 13th term. When it says a sub 13, that means this guy is the 13th in line. So by doing that, we now have an n value of 13, and we have an a sub n value of 30. We don't know what a sub 1 is because it didn't tell us the beginning. We're going to use the same formula. We're just going to have different things that we know in this problem. So in this problem, we know that one of the terms in the line is 30. We don't know what the first term is, and we know that 30 is the 13th term in the line. So from giving us that one single answer, they actually gave us two pieces of information. They gave us an n value and a term value. Our difference, then they tell us, is 3 over 2. So to find out what a sub 1 is, I get 12 times 3 halves, which is 18. So a sub 1 must be 12. But it didn't say find a sub 1. It said find a rule. So now we need to take the a sub 1 and the difference and do what we did in the previous problem. A sub n is 12 plus n minus 1 times 3 halves.
Where'd you get the a sub 1?
That was what we solved through by plugging in the 30 for the nth term and 13 for the value of n. We can solve that through and find what a sub 1 is. And then we want to use that in our formula. So we're going to distribute. And combine like terms. So I get the 3 halves n. 12 minus 3 halves is like 1.5. So 12 minus 1.5 is 10.5. And that is our rule for the nth term. Okay. So we want to use the given value as our a sub n, and its place in line is that subscript number of 13. That allows us to solve for our first term, even though they didn't give us the beginning of the sequence. And then we can do what we did in the previous problem, plugging in our a sub 1 and the common difference to solve through for a rule. Our next example is exactly the same type, so go ahead and try this one. All right, so our formula is a sub n is a sub 1 plus n minus 1 times d. By giving us a sub 8 is 50, they actually give us two pieces of information. They give us one of the terms is 50, and that it's the 8th term. So we have an n value, and we have a term value from that one piece of information. Then we're also given our common difference is 0.25. So we can use this to find out what our first term is. So I get 7 times 0.25, which is 1.75. And subtract that off gives a first term value of 48.25. Yeah, we've been working with a lot of whole numbers, and so it feels a little bit wrong, and it's not very far, like numerically away from the 50, so it seems like they should be further away if they're 8 terms away, but we're only adding a little bit to this. So we want to take that and take the difference and now plug them into the rules. So a sub n is that 48.25 plus n minus 1 times 0.25. Clean it up by distributing. So we get 0.25n minus 0.25. And then combine like terms gives 0.25n plus 48. One way to check your final answer on this is to go ahead and plug in 8 again and make sure that you get 50 out of it. Because if it's right, we should, because we know that that is a value in this line. So we can kind of check our final answer there by plugging back in and making sure that we get that point that we were given. You don't have to, but it's one way to confirm that your equation's right. One more type of problem to look at. So these problems have kind of progressed us through. In the first one, we had our a sub 1 and we had the common difference. So we had everything we needed for the pattern. In the last problem, we had the common difference, but we didn't have our a sub 1. In this last type, we don't have either of the things we need. We don't have our common difference, and we don't have our first term. So what we're going to do is find our common difference first. So I can't just subtract these two terms and say that's the difference. 45 is not the difference between each term because they're not right side by side. They're some terms away from each other. But 55 minus 10, 45, is the difference over how many terms? How many terms away are they from each other in line? 15 terms away from each other in line. Oops. So if we do that, 45 split up evenly over 15 terms tells us each term then must be changing by 3. Okay? So from the 6th term to the 21st term, we gained 45. That was over 15 terms in line. And if we're doing exactly the same thing each time we must have been adding 3. So that's our common difference. So now we have our difference, and we have 2 terms. It doesn't matter which one you use. I usually like to work with smaller numbers, so I'm going to pick the one with the numbers that I like better, but it doesn't really matter. You pick one of them, and this becomes now exactly like the previous problem. We're going to take whichever term we picked and plug in its value as 10. We don't know a sub 1. 10 was the 6th term, and we solved for a common difference of 3. So 6 minus 1 is 5, times the 3 is 15, thank you. And subtract gives us a first term value of -5. And now we have first term and common difference, so then we can write our rule. A sub n is first term plus n minus 1 times d. Distribute. And combine like terms. Here we could actually confirm this is right by using either one or both of the points, that if I plug in a 21, I should get a 55 out of this thing. If I plug in a 6, I should get a 10 out of this thing. And if those work, then we know that we found the correct rule on this. Questions? Okay, one more example like this one, so go ahead and try this final example. So our first step is finding the common difference. So between these two terms, we went from 10 to 110. So we went 100 different. But since they're not right side by side, we have to think about how far apart are they. 30 minus 5, they're 25 terms apart. So if we changed by 100 over the course of 25 terms, each term must have been changing by 4. And that is our common difference. We then want to take either one of the terms, whichever one you like better. I usually like smaller numbers, and the common difference, and plug them into our formula. So a sub n I'm going to use as 10. A sub 1 we don't know. N is 5. And the common difference we just found was 4. 5 minus 1 is 4. Times 4 is 16. And we get a first term value of negative 6.
Why do you use the A5 equals to 10 rather than the other one?
I just like smaller numbers. But using the other one, you should get exactly the same answer. Then we're going to take our a sub 1 and the common difference and plug them in. So a sub n is first term plus n minus 1 times d. Distribute. And combine like terms. And if we plug in either one of those two starting points, it should confirm that this is the right formula. Your assignment tonight is from 11.2, and make sure you read your directions because it might ask you to do more than one thing.